Hey kids, I am in meetings today, but lucky you, you can still have a math lesson. So make sure that you are attentive, taking good notes. You know that there's going to be some homework, and you'll be totally capable of doing that if you are taking great notes and paying attention and you follow along here. So today's objective 58 says that we are going to reason from a context graph or table after knowing which quantity is the input and which is the output. So basically we're going to make sense of input and output based on different ways that they can be represented, and we're also going to learn some new important vocabulary words. So we have previously learned that the input refers to the x and the output refers to the y. And so a couple new vocabulary words that I want to introduce. The first is domain. And its opposite is range. Just like x and y's are opposites, input, output are opposites, domain and range are opposites. And domain and range refer to all of the values that can come out of a function. And once you get them down on paper, the domain refers to all the x's, the range refers to all of the y's. That may sound a little abstract right now. You'll see some examples of that in a couple of minutes and it'll be a little bit more clear. The other word pair that I'd like to share with you, you may have heard of already in science class. They are independent and dependent. And the dependent variable depends on whatever is happening to the independent variable. So let's say, for example, you are measuring the temperature of water. That depends on what you are doing to the independent variable, the water. What are you boiling it? Are you freezing it? Whatever. And so the dependent variable is always dependent on something else. It's the thing that's being measured. It's the outcome. One trick that might help you is all of the x terms, see in the x column here, have the word in them. A former student discovered this. I wish I could remember who it was so I could give them credit. I didn't ever learn that in any math teacher place. That was a student's observation. I thought it was fantastic. So all of the x terms have in them, and man, if you could remember that, that's super helpful. Okay, so before we get into more particular examples, when we start really dissecting them, let's just do kind of a brief review. I think we know how to do this already, but I don't want to assume anything. So you should have gotten two colored things, markers, pencils, whatever, that are different in color. So don't pick pink and fuchsia or light blue and dark blue. Pick completely different colors. And then I would like you to highlight the word output in one color and highlight the word input in another color. So when I do my example today, I'm going to do all my outputs in green and all my inputs in orange. Okay, so remember that output refers to y and x input refers to x. And so we know that a coordinate is made up of an x and y value, xy, xy, xy. So that means the first number in every coordinate is the x, or the input. And the second part of every coordinate is the y, or the output. And when we put those coordinates on a coordinate plane in the form of a point, the x-axis, that's the horizontal one, that again is still our input. And the y-axis is our output. And so this is kind of cool. So see this point here? 1, 2. The x is 1. X-axis is 1. And the y is 2. So here's the y after I've gone up or right 1, I'm going to go up 2, so that they correspond with one another. Hopefully you knew that already. If not, oh, we'll get to practice that someday. Okay, if we have a table like this, input, of course, is the X column. Output is the Y column. I don't know if you noticed, all of this data is the same. It's just represented differently. So here's a coordinate, here's a graph, here's a table. Here's our domain and range. See if you can highlight that one for me. That range is the Y. Domain, doma in. That's the X. All right, here's a word problem. Just after the new year, everybody's making goals. Abby wants to run a 5K. On the first day of her Couch to 5K running program, she ran for 2 minutes. On the third day, she ran for 4 minutes. On the fifth day, she ran for 6 minutes. On the seventh day, she ran for 8 minutes. And so on her plan, the distance that she's going to run is dependent on the day that she is on her training schedule. So that would make the running time dependent on the day. And remember, again, dependent is a Y term. So that means the time, 2 minutes, 4 minutes, 6 minutes, 8 minutes, all of these times depend on, oh no, I did that backwards. Sorry. Knew I was going to do that. You guys have no idea how hard it is to hold my phone, talk articulately, and write at the same time. And I just knew I was going to color code that backwards. All right. So that was the time. The time that they run is dependent on which day she's on. There we go. First day, third day, fifth day, seventh day. Great. And that's demonstrated down here too. Day is independent. It's pretty objective, right? The day doesn't depend on anything. It just, days go in, days go out. Whether or not you want to run doesn't really affect that. But the minutes that we run, that's what's dependent on the day. So this is the Y and the X, or input and output. All right, take a minute. If you haven't caught up, you can pause this and label up your pretty resource. And I'm gonna keep on chugging along here. Okay. So you will notice this is a very big page, and this is a gigantic picture of all of the ways that we can consider X, Y, input, output, domain, range, independent, dependent. And that's kind of the focus of this objective, is to put it all together and really dissect what these things mean so that you are knowledgeable moving forward. So this is a table that tells the cost of gasoline for the number of gallons that I purchased. Now I just have to put a disclaimer on here. We're going to assume that I have a 5-gallon gas can. Let's say that I'm mowing my yard. That's wishful thinking because there's snow in my yard right now. And this is assuming on a particular day. We know that the cost of gas fluctuates. I just know someone's going to split hairs on me later, so I'm just going to put that disclaimer in there. So this is the number of gallons. That's the number of gas. If you look at that for a second, what's the cost per gallon of gas? Yeah, $1.99. Okay, so the cost of gas depends, obviously, on the number of gallons that you purchase. So if you purchase not very much gas, it's not going to cost as much money. If you're going to buy a bunch of gas, it's going to cost more money. And so that means that the cost is the dependent variable because it depends on how much gas you buy. So we know that's going to be the Y, right? And so that means the number of gallons is the independent variable. So that's going to be the X. Remember, all the N words are the X's, or the inputs. All right, so we can go back to our table and we can label this. So independent X gallons, I'm going to put an X here. Dependent Y, the cost, that's my Y. Okay, so we did that. All right, so is this a relationship? Yes or no? Absolutely, yes. Because any pair of numbers can be a relationship, either mathematically or randomly paired up. Now, is this a functional relationship? Yeah, every X has its own Y. There aren't any repeats of the X. They're all different numbers, so we don't have to be concerned about that. All right, just to kind of give an example of what a non-functional relationship would look like. What if you went and bought, 2 gallons of gas, and she said, okay, your total, the cashier says, your total is $3.98 and $5.42. Like, you can't have 2 different prices for the same amount of gas. That would be a weird thing. We'd be thrown off by that. It's not functional. So that's an example of a not functional relationship, but this one's functional. All right, so now that we talked about that, let's look at what a graph of that would look like. So I have a graph started for you, and when we're graphing things, we just, adjust our scale to suit our needs. So let's see, our X value is the gallons. So here's my gallons of gas, and this is for 1, 2, 3, 4, 5, etc. And so forth, gallons of gas. And then this will be Y, and that's my cost, so Y. This is going to be my money axis, and we're not going to get this perfect, right? $1.99, well, who knows where that's going to be, but it's just about 2, right? So if we graph this, 1 gallon is just about $2. 2 gallons was about $4. 3 was about 6. 4 was about 8. 5 was about 10. I'm not going to keep going because that's as much as my gas can will hold. And so, would this pass the pencil test? Yeah. If I pass my pencil across, it's only going to hit 1 point at a time. And so what does one of these points on this line represent? Ooh, let's draw the line in. Actually be a line segment. If I drew a line, that would imply that I could buy more gas. But again, I'm going to max out here, right? So let's just pick a random point here. So this is point 2 over and 4 up. What does that mean? If I buy 2 gallons of gas, costs, I'm going to do this about, that's a little about symbol, $4, right? Yeah, cool. This makes sense because a coordinate is made up of X and Y values. We've talked about this before. We did that in the previous page, right? Where we were labeling and color coding. So again, when we are graphing, remember that, I need to remember what color I made what. That this is my input, and this is my output. Sound effects make this stuff fun. All right, and, oh man, I just threw my pen cap. Can I write this using function notation? What I mean by that is, remember last week we did this f of x? What do I do to my x to get my output? Imagine this is my output and I need my input. What am I doing for what am I doing to each of these numbers to get this? I'm multiplying each of those numbers by $1.99, right? $1.99 times x, or 1.99 x. I kind of guided you through that one. We're going to do more of those in our next lesson. Okay, so let's do some practice here. Which of those variables was the input then? It's the gallons of gas. And what was the output? Yeah, the cost. Kind of makes sense. I put gas in my car and I take money out of my wallet, unfortunately. Okay, so let's talk about the domain. The domain is all of the possible amounts of money. All the possible amounts of gas that I could purchase. So it's possible I could purchase no gas, right? So 0 gallons. And it's possible that I could purchase 5 gallons. And all of the amounts of gas in between. I could purchase 1 gallon, 2 gallons, 3 gallons, 4 gallons. I could also purchase 3.12 gallons or 2.5 gallons. So all of those numbers in between, I can buy for gas. And we're going to use brackets around those numbers. Again, for all of the possible X values. Just going to label this gas so we know what that was later. And now the range is all of the money. If I buy no gas, that's going to cost no money. If I fill up that little gas bucket, we know that we max out at $9.95. I can spend $9.95 and anything in between. So that's all the Y values, or that's the money. Okay? All right. Take a minute and pause this and fill in anything that you missed. And on we go. But wait, there's more. Another one. Woohoo! Not every situation is the same. I thought I'd give you some variety here. And we have just finished with the polar vortex of 19. Wow, that was a while ago. 2019. And so I thought it'd be fun to make a math problem out of that. So I have found the low temperatures recorded in Rochelle. This is without the wind chill, right? We're going to use it as a word problem. Okay, so this is kind of tricky because the temperature did not depend on the date, right? However, if I am looking up the temperature on a computer, the temperature that my computer tells me depends on the date that I ask it to look it up for, right? So, for example, this 10 was dependent on the date that I punched in. This 10 was only going to come out if I punched in 128.19. So in that case, it is dependent. The temperature is the dependent variable. This is kind of a tricky thing. That's why I wanted to do a variety. And then the independent variable is the date. And so, what would the input be? Yeah, the date. And the output will be the temperature. Here's a little helpful hint. Usually on a table that is not labeled X and Y, usually the X is on the left and the Y is on the right. Not always, but often. Hey look, we have a special guest. Say hi. Meow. Just had to share that with you. Okay, sorry. All right, so let's go back and label the X and Y table. Oh, actually, we did that. All right, now, is this a relationship? Absolutely. These numbers are related. On this date, it was this temperature. On this date, it was this temperature. Yes, any pair of numbers is a relationship. Is this functional? If you ask me, there's nothing functional about those crazy temperatures. Is this functional? This is a trick question, isn't it? How many of you are wondering about this? Every X has to have its own Y, but Y is going to have multiple X's. So this is a functional relationship. Great. Okay, So let's see what this would look like on a graph. Is every graph going to be pretty? Heck no. And do you have to kind of blaze your own trail and make your own rules to make it make sense? You sure do. So here you'll see on the x-axis a bunch of blocks. Well, how do you label a date on there, right? Well, in my mind, it would make sense for this to be day 1, day 2, day 3, day 4, and so forth. So I'm just going to put a little 1, 2. And if you want to do something else, you can, but this is how it makes sense to me, right? So this is going to be day 1, 2, 3, 4, 5, 6, 7, and so forth, right? Good. And now I have a range that goes from, my lowest is -29 and my highest is 37. I don't have 37 boxes, 60 boxes much less, so I need to make an executive decision. What if, say, for the y-axis, one box is 3 degrees. We'll go with that. Okay, so then, on the first day, the temperature is 10 degrees. On the first day, the temperature is 10 degrees. It's not going to be perfect. 3, 6, 9, and a little bit higher than that is 10 degrees. Day 2 is -17. 1, 3, 6, 9, 12, 15. Look at that difference. Right? Okay. Day 3 was -26. Awesome. 3, 6, 9, 12, 15, 18, 21, 24. It's still going down. That's the day my heat went out. That was awesome. And then -29, that was Wednesday. I keep going here, almost to the very bottom. Nice. It's the day I got my heat back. And we were happy. Okay, and then, dun dun dun, 9 degrees, heat wave on day 5. So day 5, 3, 6, 9. And again on the next day, because we're consistent. And then today, I went for a run today. It was 37 degrees. It was amazing. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Ruh-roh. Keep going. That's all right. Goes off the grid. Wow, look at the difference between these two. That's huge, right? Okay. Does this pass the pencil test? Yeah. Because you can't have 2 different low temperatures on the day. You can have a bunch of different temperatures, right? It can be, I don't know, 5 degrees in the morning and 20 degrees in the afternoon, but there's only one low temperature. That's what a low is, right? It's the lowest point. So, does this pass a pencil test? Yes, it does. What does it mean? Well, let's just pick an example here. Here's a 0.53. So that means on the 5th day, which was the 1st, it was 3, 6, 9 degrees. And we found that because 3 times 9 degrees, 3 times 3 degrees, every box is worth 3. It comes out to be 9 degrees. Cool. Can I write this using function notation? No, right? This is not mathematically generated. This is Mother Nature, and she doesn't go by math, as far as I know, so not possible. And sometimes that happens. And so what's the domain? Back to the top. Domain is in domain with an IN, that's the X, so that's the date. And so therefore the range is the temperature. Isn't it cool how this all comes together, right? Oh, sorry. Let's write the domain in there. Sorry. So this domain is a little bit different. So when we did the... Here, I'll show it to you. When we did the amount of gas, right, we said that you could have 0, 1, 2, 3, 4, 5 gallons of gas and all of the tiny measurements in between. But we don't really, well, we don't, not really, but we don't record our date, anything in between. We say it is the 28th, and then it flips to the 29th. There's no middle measurement, and then it's the 30th. Having a really hard time not making mistakes. 31st, and then the 1st, and then the 2nd. And if you can put these in ascending order from small to big, that is the best form to write that in. And so, how about the temperature? Now here's the thing, because this is the low temperature is all of these individual numbers. It's not all of the temperatures in between. It just includes these numbers as the low. So I'm going to do my bracket. And again, I'm going to do ascending order. So my smallest one was negative 29, negative 26, negative 17. 9 happens twice. I'm just going to write it once. 10 and a balmy 37. So my domain, my x values, started at the 28th and went to the 3rd. My y values included a range from negative 29 all the way up to 37 and hit these numbers in between. So cool. Maybe that makes sense to you. I hope it does. Okay, so it's time for practice. You get to do some homework. Okay, here we go. So you'll notice that your homework looks very similar to your notes, but it's not exact because I needed to make you think somehow. So I'll get you going, and you know what? Let's look at your redo side. I just don't want to rob you of a opportunity to learn, right? So here we go. So on this side you have number of students per class period. This is real information in case you care. And this is converting tablespoons to teaspoons. This is skills for life, guys. You're cooking. All right, so you'll have the table up top. What would a graph of this function look like? So again, you do a system that makes sense to you. So you may want to do 3rd hour, 4th hour, 5th hour, 7th hour, and so forth. You can do that, or you can do 1st class of the day, 2nd class of the day, 3rd class of the day. I don't care what you do, as long as it's logical. Obviously, there's not, up to 27 little boxes that go up, so you can make each box worth something. Maybe write it in the side here. Each box equals some number of students, or you can start numbering at a different number. Just don't start at 0. Maybe you start at 20. Just write it in a little 20 there. 21, 22, 23, whatever makes sense for you. Does it pass the pencil test? Pick a point on that coordinate plane. Tell me what it represents, just like what we did on our notes. And then tell me, is the input the x-axis or the y-axis? The first side is a little bit different. Which represents the input, which represents the output. And these bottom questions are basically the same, just scrambled up here. Is this a relationship? Yes or no? Circle. Some of you guys get cute about, crossing things out. Just circle. For the love of Pete, just follow directions. Circle. 1. Is it functional? Write a relationship, so that would be one of these. If possible. Sometimes it's not possible. Don't forget to go up here and label your x and y. So one of these is x, one of these is y. And then tell me, is domain this or this? Dependent, this or this. Input, this or bit, and so forth, right? Cool. All right, I tried to talk as fast as I could, even though that's a long lesson. My phone says a half hour, so that means you should have about 10 minutes to be working on your homework. And you know what? Practice makes maybe not perfect, but better. So if you finish this whole side, you could do the back side. And if you finish that, you could find a friend who has also finished theirs and compare. Don't give your answers away, but you can compare. See if you agree. If you disagree, have a good conversation about who's right and who's wrong. So, cool. Can't wait to see you guys when I get back. Have a good day.